Good morning, everyone. Hello, hello. So I hope everyone is having a good time here in Yokohama and had a good dinner last night. So again, thank you for the local organizers for taking care of us. All right, so welcome to the Disaster Mitigation Working Group session this morning. We actually have two sessions. This is the first, and then we'll have a tea break, and then we'll have the second session. So full schedule for this morning, but we look forward for all the speakers in their presentations this morning. All right, so just a bit of a background about this working group. So the Disaster Mitigation Working Group aims to build up capacity of hazard risk analysis by case studies based on deeper understanding approach. So this has been happening, this session has been happening for a decade already, since 2015. I only came here around 4 years ago, but this is a very, very good working group. Anyway, so aside from me, Franz De Leon from the Ministry of Science and Technology back in the Philippines, this is co-chaired with Eric Yen from Academia Sinica Taiwan, and of course we have Chai over there from HII. So let me just quickly turn over this microphone to Eric to give a few short words before your presentation. All right.
I have mic here. Thank you, friends. Morning, everyone. Just some catch-up and also updates of the regional collaborations. As you heard from friends, the keywords of the collaboration in the past few years is the deeper understanding to the science behind the hazards. As you know that in the past 5 or more years, we've been working together, conducting more than 20 case studies, and we learned from those collaborations. Based on the numerical simulation supported by the scientists, like Professor Lin, who is the speaker later. Based on the understanding of the Earth systems. People learns, people learns the nature of phenomena by observations. However, the observing system sees only part of the Earth systems in certain space, time, or spectral regions. Coming to the digital age, numerical models are the, it's a bit complicated of this one, but this is the best one I could find, explaining the Earth system models for the numerical simulation. Actually, that's a core concept of the original collaboration, as I mentioned. So observation have some limited. We make use of the numerical simulations and also the scientific models to bridge the gaps, to generate the data between the desired ranges based on the up-to-date knowledge to the interaction of the atmosphere, land, and ocean, and also crowd space. That's the basic scopes or components of the Earth systems. So through the model data fusion, the integration of the observation data and also the numerical models, and then we can use to inform the prediction by modifying the initial conditions for the future forecast simulation. Observations can also be used to train a model to improve the parameterization. We learned this kind of processes in our past case studies leading by Professor Lin and other scientists in different countries. So that's also a opportunities to deploy the modern machine learning or AI models to improve the numerical systems. Exactly the way what Google or other advanced research groups are doing. So the keywords here are knowledge to the Earth system, the fusion of model and observation, and data cubes. I'll explain the data models and the concept in later slides. And Professor Lin also later will tell us about the theory and practices of the numerical simulations. Capacity building is the core strategy of the collaboration, as we learned in the past few years. Based on the deeper understanding, as I mentioned, the purpose here is to improve the knowledge and ability to analyze the risk quantitatively and to predict the potential impacts with better accuracy and efficiency. So after those cases and the collaboration, we hope that partners could also learn how to develop their models or collaborations for their own needs to engage the local user communities, and with the support from the scientists from the Asia region. So from each case study, we develop the best practices and also risk analysis capability based on the knowledge and numerical simulations. So all the outcomes from the case study, the data, knowledge, the tool, algorithm, anything are shared. And also, luckily, we have the open and sharing data working group who can support us in the future, in a much standardized or much common way, linking with the community around the world. So engagement of the local user community and the service provider are very important because we hope the outcomes could be easily shared and easily accessed to any partners. So we also welcome the partners to bring their own needs. Together, we can identify the required services and supported infrastructure. And from last APAN, about a year ago in Thailand, we also extending the scope to sustainable development goals from partners. And it's I think this collaboration deserves a long-term investment of all the partners because we are transforming the outcomes into services for us all. So we keep developing the best practice from the case study. We also conducting several masterclass from 2016, started from the APAN meeting in Indonesia, and then later in Singapore and New Zealand. And then the last one is in Thailand, 2024. So of course we learned a lot from the partner, from the third-party contributions and other projects. We also extending from the natural hazards to sustainable development goals, sorry, here's a typo, and to the satellite resources. So the APAN is a collaboration platform for these collaborations, and also for the engagement of different communities. And another good platform is IIGC, hosting in Taipei. And then we have different participants from different communities. And this is some summary from the last class in Thailand last year about the Sustainable Development Goal. So as we already know, learning from the AI efforts, we also need the infrastructure, the data, the tools, working together to improve the disaster mitigation or risk analysis based on the numerical simulations. Again, we hope to grow in the capacity from the case study by integration of the machine learning-based data analysis and applications. Because the Sustainable Development Goal, that's a country or a space a location specific. Each one has different issue and different focus. With there's no single approach for reducing the risk appropriate across all settings. So what we understand here is that we need measurement to collect data continuously and persistently to build up the monitoring capabilities to understand, based on the metrics, how the situation is going. And then we can modify the analysis or the monitoring or the practices, and also to issue the warnings to ensure that we are on the right track. Luckily, now it's possible to have this in place based on the numerical simulations. The other thing is that we in Thailand, we also have several sessions to have a space agency, different countries working together. So Earth observations, of course, plays a quite essential role for the risk analysis, and also now it's possible to get in the knowledge and Earth intelligence from those satellite resources. And here are some of the examples of the space agency in Taiwan. They've been carry out some case study, for example, working together with Thailand to monitoring the land use based on the paddy field, the rice field or the sugarcane fields. And then some other risk monitoring, such as the oil leaking on the sea or the volcano eruption situations, road traffic impact, etc. What's essential behind? That's the ARD, analysis ready data, with the data cube data structure, and also the service platform. The ARD, analysis ready, that means the satellite image providers, they are in a very good place to provide those information which is user could get it easily and make it analysis pipeline available right away by reducing the duplicate efforts for some complex pre-processing, such as the cloud removal, the rectification of the geometry, and also the radiation things, which is also some barriers about the knowledge behind the satellite data. So in Taiwan, we also have been built up such production systems based on the open data cube systems, and provision the satellite images in the analysis ready data format to the end users, and also contribute to some of the sustainable development goals together with different partners around the world. So the top right, that's the future development plan to make the federation of the distributed open data cube systems available, which is much easier for the federation of heterogeneous data sources. Of course, all these designs are based on the requirements from the users. So all these are building the capacity for the future challenges. In addition to the sustainable development goals, we also facing the highly complex spatial-temporal problems from different case study, the model uncertainty, the requirements from different partners and the local needs, and how to access to the proper data from different sources in terms of the space, time, and quantity. And also the changes of the Earth system components is also natural and continuous. So we have to develop the predictive capacity together. We are not alone. We can work together based on the knowledge and physics, science-based, and also integrating the data science approach. The other core concept is sharing. Yeah, we can grow together by sharing the knowledge and tool and data we have through the collaboration platform, as I mentioned. So IGC 2025 is coming 2 weeks later in Taipei. The theme this year is AI and hybrid quantum computing. So we have one day, a whole day workshop about the hybrid quantum computing, a whole day about the AI masterclass, and of course we have the environmental computing workshop there. So you are all very welcomed to come to Taiwan and sharing your ideas about this. So that's my report about the regional collaborations. Thank you so much.
All right. Thank you very much, Eric. Any questions, comments? Go.
Well, I'm wondering about TASA.
Yeah.
Because they give data queue training workshop.
Yes.
At APAN57. Yeah. But after that, he disappeared.
No.
Yeah. So
okay.
This has to be like continue, which is very good. In Thailand, NECTEC tried to use this to data queue to update the agri-map that what they have, but he still cannot. But I wonder what happened to TASA has disappeared.
Yeah, we have quite close collaborations. He's just not able to come to APAN. But
no, it doesn't have to come here. Continue.
Yeah.
We can talk after because no need to be at APAN to continue.
Yeah. Some examples from our center, AGC, we are providing the data cube services together with TASA in Taiwan. And we are also working together for the Sentinel Asia services. The cloud, we host the cloud services. And TASA is also one of the data providers, and also GISTA and also FIOSA, many space agencies around Asia. Yeah. So maybe next time, in next APAN meeting, we can organize another session for the space agencies. Talking about this.
Continuous how to use the queue.
Yes,
the thing
that's
is,
right.
Don't need to be only just another workshop at APAN.
Sure.
Because the account that he provides and with his staff
in any format we need
after APAN, so you cannot do anything.
Yeah.
Just like need to be continuous.
Yes.
Not just like come to APAN and then if not coming, I'm not there. No need like that. We can continue.
So the
and data queue is very useful.
The short answer is no problem.
Okay.
Yeah.
Okay.
All right. Thank you, Eric.
Thank you so much.
Any other question? If not, all right, so let's move to the next presenter. The next presenter is Dr. Chuan Yao Lin from the Research Center for Environmental Changes, also from Academia Sinica of Taiwan. Sir, please. Thank you.
Morning, everyone. Okay. Today I'm going to present about the air pollution issue. So the title is Application Across Scale Atmosphere Chemical Transport Model for the Air Quality Forecast and the Pollution Diagnosis over Taiwan. I would like to say because Taiwan is here. Yeah, actually, we because we just located at the downwind of the continental outflow during the winter monsoon. So you can see especially with the winter monsoon, the continental outflow could be brings dust and subpotential pollutant. through the continental outflow to Taiwan. And also, during springtime, also the biomass burning season. Biomass burning season under the favorable weather condition can transport to this region and maybe can downward to affect Taiwan's air quality. So that's why we need to a cross-scale, I call it a cross-scale simulation, because there's a lot of area, okay? So with the air quality over Western Taiwan, there is also strongly impacted by the local emission. So this is Taiwan's nighttime. You see the mega city. In northern Taiwan, central Taiwan, we have power plants. Actually, is the huge power plants in central Taiwan and the heavy industry in southern Taiwan, Kaohsiung area. So if you check the air quality, the worst air quality, the air quality greater than hundreds, which means during the winter monsoons and the November to April. So this is around the 18 years. So you can see the worst air quality just over southwestern Taiwan, more than per month, more than 20 days. Okay, so that's we can say it's due to the emission or the complicated terrain structure or long-range transport and the local and the weather conditions. So how to generate a good mitigation strategy? So that is our focus in Taiwan currently. So let me introduce our air quality, especially the central Taiwan here. Because high mountain, you can see in Taiwan's more the peak mountain high is around 4,000 meter high. So the central mountain range actually in average around 2,000. Okay, so this is if we calculated the seasonal elevation, you see the urban coast is blue, and the red dot is urban, and also the mountain station. So you can clearly see, especially for the ozone concentration, we have a quite clear seasonal variation in springtime and the autumn season. And you might note the coast, urban and the mountain area, actually, the concentration is the highest. Why? And the PM2.5 also showing the same situation. So if we calculate, you see the nitrate in PM2.5, you see that the nitrate production, the component is over the inland area. However, our emission here, you can see that this is a highway and heavy industrial, the power plant and heavy industrial is just coast area. So why the high concentration is over the high mountain area? So this mountain quite important role, because the land sea breeze actually can, sorry, that's it. Wow. Why? Sorry. Cannot action. Oh yeah. So just to describe, you see that because Taiwan West Plain actually clear sea breeze. So sea breeze bring the air pollution and then trap over this region. So that's basically the reason. And also, if you see the winter monsoon, actually continental outflow, the high pressure continental high move over the ocean, then the flow is easterly, and interact with the high mountain. So the lee side where formation deep vortex. So that's all the reasons I would like to introduce later in detail later. So we developed under the project of the severe IoT Taiwan. We have to develop a high resolution air quality forecast and dynamics model. So this is our model structure, because it is impossible to develop by a new model. So we just based on the current the Wolfram model and input and emission from and the meteorologic from NCEP and the emission, Taiwan's emission, and also the China's from Middle Asia to the OK model and calculate for the result here. So we improved our model based on the emission, calculate the land use data and emission, and even the boundary layer estimate how to improve the boundary layer, because the boundary layer high is a significant impact on the ground source, the air pollution concentration. And we optimize the PM 2.5 chemistry by field campaign, and also the spatial distribution of PM 2.5 by multiple data set that I will introduce later. This is just an example when we improve the boundary layer. This is the original version for the boundary layer skin. So we use a new boundary skin. So as you can see, the red dot actually here is observation. So our simulation actually fail to predict the central Taiwan's spatially planned area. However, if we use the new boundary layer skins, so actually improve, even still not a good predict here, but you can see the capture enhance the concentration. So that's just an example. And another things is in Taiwan, we have more than 75 national air quality monitoring station for the whole Taiwan. And we have more than 10,000 IoT-based micro sensor network. Here, you can see quite high density. So we use this kind of data because we call this air box. So which means it is cheaper, but you need to calibrate. So we calibrate, compare with our standard station, and to improve to validate and try to find out if the sensor has a problem. We can just skip out and try to validate model forecast. So this is just an example, and try to find out the hotspot of the high air pollution, local hotspot of the pollution high concentration. So this is IoT-based microsensor networks based on validate, and this is our model predicts. So this is after the microsensor improves is quite high detail. You can see detailed high concentration location, and then after that we improve our forecast to the county specific for the air quality forecast. This is for the county forecast best. So the original in Taiwan's MOE for the previous is EPA, actually only 7 area. Only forecast 7 area. Right now we can predict in county best based on the high resolution data observation. Okay, so so right now it's just an introduction. So we have every day we forecast 72 hours. So this is a air quality forecast website you can surf, and this is right now we have the model prediction actually is 3 kilometer for forecast, and diagnostic we can use the 1 kilometer resolution. To 1 kilometer per hour to total diagnostic. So we connect all the data center, all the data bank to support and validate our model prediction. And this is all the statistic for the past few years, our model performance from 2019, 2023. You can see forecast. The accuracy from 64 to over 70% forecast. So our accuracy actually improved in that few years. So based on this kind of model forecast system, we also use this model to do the simulation to try to understand the and diagnostic the mechanism of air pollution. This is just a case for the air quality deterioration episode associated with the tropical cyclone. Actually, here I mentioned the tropical cyclone actually not directly hit Taiwan, but it just a pass between Philippines and Taiwan. And you see, this is just a case for the 2018 in July 17th. You can see the tropical cyclone here, and also following a tropical low pressure system. It's a low pressure system, and the induced easterly flow. Actually, you might know during the summertime, our monsoon is southwesterly. So, however, once tropical cyclone here, it can induce our ambient flow is easterly. So easterly flow can interact with the mountain, and in the this side of the high mountain will be weather condition quite stable, so that the air pollution can easily concentration easily accumulate. So if we check the tropical cyclone, also that we call the typhoon track, you see that 100 years, you see this is actually around 80% from between Taiwan and Philippines. So which means easily to induce and enhance the air pollution issue over the western Taiwan. So this is our simulation, try to understand, say, this is observation. So it's our model simulation. So you can clearly see the sea breeze quite clearly, sea breeze transport the air pollution to the mountain area. Actually, you might know, over the mountain area actually is not, it quite few the anthropogenic release or traffic emission. So, but you can see the sea breeze can bring the air pollution and trap to the mountain area. And I just mentioned the easterly flow actually interacts with the mountain and the lee side formation, lee vortex here. So it can trap and stable the air pollution here. So this is actually the theoretical from the lab simulation, that experiment. So showing the flow number actually less than 0.5 easily just cannot pass over the mountain, just go around from north and south. So you can see the flow, easterly flow, and to rear inflow, and at the lee side formation, the vortex. So that's the reason for why easily formation and air pollution trap here. So this is just a cross-section and hydraulic jump. You can see the lee side of the mountain. Okay, so this is just for show you the structure of this kind of episodes. Because during the nighttime, early morning, you can see due to the inversion formation, so you can see it's separate air pollution. Okay, in the residual layer has a high concentration in the near surface during the nighttime and early morning. And the 10 p.m. you see the sea breeze development and bring the pollution and couple the local pollution emission and following the sea breeze and trap over the mountain here. So that's the reason. So you can see the animation figure can easily show you can trap, and during the nighttime the land breeze transport out. So in the early morning actually can separate. So the cartoon here, I just summarize here. There's a deep vortex formation, and okay, so during the nighttime, actually, land breeze or mountain flow can trap the pollution to the coastal area. However, and you can see that during the near surface cooling, the emerging formation and the separate, and you can see the air pollution in the residual layer. And the next during the daytime, the sea breeze development and the local pollution also released. So the air pollution quickly concentration in a short times, as you can see, is quite high concentration coupled together, and the emission, low carbon emission enhance the pollution and trap to the mountain area. This situation actually is quite, the typhoon situation actually quite similar to the winter monsoon, provide easterly flow. So that's why during the winter monsoon, high concentration over the air pollution issue over the western Taiwan. The second case actually is just, I would like to introduce the NASA aircraft measurement from we call this is Asia AQ period. In IOP, and we have also done the air measurement over the southern Taiwan, which is called the Kaohsiung area. I just introduced the IOP3. So that the last year during the springtime, actually the NASA aircraft just landed in Korea and to the Philippines and pass by Taiwan, take sample. We have successful for IOP to take the sample from the eastern Taiwan to take sample in the western Taiwan, and then to the landing in Philippine area. So just introduce the IOP3, actually the 2024, March 12 to 14. The IOP3 actually is March 3. So March 13. So before the IOP, you can see the high concentration issue is ozone, and the land transfer to the PN. So this is interesting issues, and this is, you can see is the flow. The 12 here, quite strong continental outflow, and then the flow from northerly, and easterly. So you can see the March 13 and March 14. Actually, the flow pattern is different. So our simulation can show you the before the IOP. So you can see it's continental outflow, high concentration. This is ozone simulation. Already cover the whole area of this region. So at nighttime, we organize east-west. I would say it's east-west plume, high ozone concentration, more than 60 ppb transport from continental outflow to Taiwan. And the IOP period, you see, easily can see from this area, the pollution band transport to the eastern and western Taiwan. Okay, I use the models from 9 kilometer. This is a simulation area, from 9 kilometer to 1 kilometer. Okay, so I did this again. This is a validation for the background station from Phuket Cap in North Tip Taiwan, and Ma Gong and Penghu Island, and Hangchun Station. So this is all background station. The observation is here, the black lines observation. Our simulation is red line. So this is for ozone and PM2.5. Also, so you can see that this is the IOP period. Before IOP period, the quite strong wind and actually long range transport, continental outflow, accompanying the ozone around the 80 ppb and PM2.5 around 50 microgram kilometer. After that, you see the stably around the PM2.5 around 20 and ozone around 60 ppb. You can see that from north to south, actually same order. Okay. And at the city, I'm not going to detail. We also compare with the city, our model simulation and observation. So our temperature, wind speed, and the PM2.5 ozone, NO2 and SO2, and you can see the whole western Taiwan, our correlation actually is, we can capture the, I would say that we can capture the observation situation. Okay, so I just validate our model. So this is just showing the air quality measurement. This is NASA DC-8 from Korea and from Eastern Taiwan to Southern Taiwan and to the north, and north and south twice. So this is just the point here: 1, 2, 3, 4, 5, 6. So north, south, north, south. So you can find things here. This is the upper panel is ozone simulation, and this is boundary layer for the here. And the blue dot is aircraft elevation. So from the elevation to the near low boundary and to the high elevation around 3,000 meter high, and to the land to the near boundary. So that's you can see the high concentration here, here, and here. That's all passed over the Kaohsiung area. It's a big city in Taiwan. And we compare this is elevation, the aircraft track here, and the observation for the aircraft measurement and our model simulation around 60 ppb, quite stable. Even down to the near ground surface and to the 3,000 meter high, 3,000 meter high, the concentration nearly 60 ppb, which means it's a well mixed in the below 2,000 meter high, or the concentration or the ozone concentration all high. Okay, so this is a Kaohsiung area, pass over the Kaohsiung area. Okay, so we also validate the aircraft measurement, formaldehyde and the PAN. Actually, so we can capture, except for the NO2, because unsupported pollutant release near background area, near surface area. And you can see that we can capture where for the trace gas for the formaldehyde and the PAN. So our question, scientific question, is here. This is just a counterthesis of the Professor George Lin. He proposed that northeast flow can formation a deep vortex over this here. But our question is, when and how do the formation of the vortex and the Leeweg effect here impacts the air quality of the Kaohsiung area? Kaohsiung area is here. So that's our scientific question. So I just would like to show you, this is before the IOP. So you see, if you remember, before the IOP already has a long-range transport pollutant. So this is the ozone concentration. So it's high mountain here. So the long-range transport just the east and west of Taiwan. So you will see the southern tip of Taiwan actually can pass over because mountain. Later here I can show you. And during the nighttime, because titration, ozone, low concentration in the deep vortex formation at the nighttime, and a pair of deep vortex. The north one you can see is due to the anthropogenic release locally and the ozone titration. But however, here can support the ozone concentration to the south tip of Taiwan. So if we have the two cross section here, because here pass over Kaohsiung area, the mountain height is still 2,000 meters. So actually, the air, the air mass cannot pass over the mountain. So you can just see the western side and eastern side. The western side just trapped over this region. But however, to the south, the Pingtung area can pass over, so can support the actual ozone concentration. For the IOP period, you can see that the early morning still deep vortex formation still exists. So however south part you can see is just pass over, and another plume coming, and so you can see the trap here. Again, the high mountain is cannot pass over to this region, but however south part you can still can easily pass over. So during the next day, so the you can see that this is a PM, ozone is a PM 2.5. So you can see it's a high PM 2.5 just over Western Taiwan. So we also compare with the component of the air traffic measurement. So though we have two local station measurement, so we compare our model simulation. So the heavy is observation for a different station, and the light is a simulation. Actually, you can see after the IOP, the nitrate concentration increasing, still increasing. So I think that's the you can if you check the station, you can see after IOP, ozone concentration is increasing, and the PM2.5 also increasing. That's why this is due to the high environmental ozone concentration actually provide oxidation, atmospheric oxidation, and enhance the secondary aerosol formation. Okay, so that's the story. So the 3 dimension showing during the periods, you can see the concentration eastern side pass over this region and mix with the local. So you also find in the vertical, the high concentration is not at the ground surface, actually around the 1,000 meter high. Okay, so I think I summarize here because the central mountain range actually is very important for the flow pattern interact with the mountain, very important role. And the formation of the vortex allow the pollution to accumulate and create a high ozone environment that favor the secondary aerosol formation. That's why after the IOP, we have a quite high concentration, the PM 2.5. Okay, so we still need the observation data to identify our finding. Okay, I think I stop here. Thank you.
Thank you very much, Dr. Lin, for your very insightful presentation. Now we open the floor from some questions or clarification. Yes, please, sir. There's a microphone over there.
Thank you. Douglas from New Zealand. So like Taiwan, New Zealand is to the east of Australia. And
Oh, yeah.
we often get, when they have big bushfires, we get very beautiful sunsets.
Okay.
But we do not have the pollution. So my question really is to do with one of your earlier slides, where you were showing the causes of the pollution and where those pollutants were coming from. So I know that you've been talking here about forecasting in Taiwan. I just wanted to go back to that second slide that you showed there, the second slide, top middle.
This one?
That one.
Yeah.
And so you have the 3 main causes of the pollution coming to Taiwan.
Yes.
So you are at the mercy of those locations.
Yes.
I think we all know that those problems or those sources of pollution are also problems for those countries, like in Thailand. I know they have problems with burning off. In China, they have problems with dust, etc. So my question is, the way that you are going to solve the problem in Taiwan is to have the solution in those other locations.
Okay. Good question.
And I know that's
and difficult question.
I know that you cannot solve that. So my question really is, if the Chinese are planting trees in the Gobi Desert,
Yeah.
and if the Thai government is stopping burning off of stubble, for example, in the areas,
Yes.
that will, in 10 years' time or 20 years' time, that will solve
Yes.
the problem in
Yes.
Taiwan. So are you, as Taiwan, working with any of those other countries to try and solve the problem at the source, or really is that outside of your control?
Okay. As for the first question, actually, we have our own, and if we because I don't want to present it, because the continental outflow actually below the 1,000, usually below 1,000 in the low boundary transport from continental outflow. However, biomass burning actually you need to have a strong upward motion. So the transport to Taiwan area, I do not present here, but today. But the transport to Taiwan actually is between 2,000 and 4,000 high. So the elevation is different. That's that I would like to say that. So if we check that, but under the favorable condition, it can downward. So outside the country, the Taiwan actually, it's difficult for us. So we needed to, under the situation, once we have a long-range transport issue, so we need to control, for example, the power plant. We needed to lower down the pollution release. So that's what we can do.
Yes, yes.
And alert the pollution coming when coming. So the people can do wear mask, something like
Yes, yes.
protect their health. So that's it. Our understanding for the in the past few 10 years or decades, actually, continental outflow, the emission actually in China actually also has a good control. It's decreasing. Yeah,
It's decreasing.
it's decreasing. But even decreasing, only 1% transport to here, our concentration still high. Okay, that's during the event. I mean, during the event. And Gobi Desert. Gobi Desert, if you check the data, actually also decreasing event. But yeah, it is due to the control. Once it is control, but due to the climate issue also, because the continental outflow, it's decreasing. The trend is, I mean, the continental high is decreasing in the long-term point of view. It's decreasing. And the biomass burning, actually, Chai is quite
I understand.
familiar with that part. Actually, every year, more than 10,000, as I always say, it's more than 10,000 fire hotspot if you check from the satellite. So I think Thailand also try to reduce that. I think not only Thailand, but also the Vietnam in the north.
I think
Also,
Indonesia also has problems with that same area.
Yeah.
I mean, when Australia has very large fires, like I said, we have very beautiful sunsets in New Zealand.
Yes.
So
Yes.
we don't have any problem. Every 5 years they have a big fire, and then everybody is looking, oh, the beautiful sunrise, beautiful
Yes.
sunset. We're very happy. But
Yeah.
in Australia, they're very unhappy.
Yes, but you see the biomass actually is usually between 2,000 and 4,000.
Thank you.
Yeah, that's right. Yeah.
So it's called from Thailand, right? Actually, I just got information beginning of this year.
Yeah.
It's from the forest, 64%, and then from the agriculture is 26.8%. Besides that, it's also from Myanmar and Laos.
Yeah, right. Not just I would say Southeast
No,
Asia, not
no.
only from Thailand.
What I'm saying,
Yeah.
I'm trying my best with our organization.
Yes.
We have a good practice for changing from the monocrop.
Yeah.
It calls from corn for animal food.
Yes.
So that's why we try to expand the work that we have been done with changing from monocrop to integrated for the forest, the forest,
Yep.
agroforestry. So just to let you know, and we need to work closely. And actually, the professor that working close with me, she also working on a PM 2.5.
Yes.
Maybe we can set up some kind of project to solve your problem and our problem also.
Yeah.
Thank
Actually,
you.
the biomass burning emission always the large uncertainty in the model simulation. Actually, during the NASA air quality study periods they prepare from satellite and down, top down, and actually also the bottom up to try to improve the
We
biomass burn emission.
we should develop this project together
Yeah.
to solve your
sure.
problem and our problem.
It's important.
That's our mission. Okay, thank you.
Okay.
Yeah, I'll add a bit. I don't know, but when you analyze the data from this Asia AQ project, it went to Thailand. Okay, before they publish it, NASA asked me to
Yes,
give
yes.
comments. But you seem to have a lot of information and from the flight itself,
Yeah.
because this guy, James Crawford or something.
Yeah, James Crawford. Yeah. Right.
Try to explain the result for Thailand, but it's still uncertainty that only the flight can tell. Maybe biomass, maybe from the city, but some scientists in Thailand concluded already it's about biomass. That's the cause. But so how to get into his result?
As we have,
Analysis that he
you
has
mean the
done.
data, observation
not,
data?
Not the data, because I get it. I don't know how to, but
Yeah, we have
just the
we have-
analysis that they have done for the project
Yeah.
yeah.
Yeah, right now they provide an account and store and the cloud data storage.
Okay.
We can
Yeah, point me
download. So
to
if
that.
we join if you are
they,
also, join
the
the
Thailand Space
project.
Agency joined the project with NARIT. I think NARIT the
Yeah.
astrology.
Yeah.
But the result is unclear. It's
Yeah,
just
yeah,
like
right. But by the way, that the model can help. Yeah.
okay.
So you can do some sensitive test to check if it is due to the biomass burning and subogenic pollutant. And also the downwind side, actually in Taiwan, we have isotope measurement. So you can check back for the chemical analyze if it is from biomass burning or subogenic.
Okay. Because the NASA is not concluded, but the people in Thailand already concluded. Like, what? So
Really?
I would like to see the original, but they never referenced where they got those information from.
Okay.
Difficult. Okay, point me to that. Thank
Yep.
you.
A few more questions, quick questions. Dr. Reed, I saw in one of your slides that in Taiwan there are 75 national stations, and then there are more than 10,000
Yes.
IoT monitors.
Yes.
How did you do it?
Because the IoT sensor actually is cheaper. There's the Taiwan Education Ministry of Education support the funding to build up the sensor, and the EPA, and the Taiwan EPA also.
The main station in Thailand, 12 million.
12 million.
It's like 3,000 baht, but you can have a lot. But the quality different.
I would say the airbox for the chip sensor is below 3,000 NT dollars, around 3,000, one for one. If I remember, it's right. It's a cheaper one, but it has uncertainty. So because it's a cheaper one, so you need to validate. Yes. Yeah, and because it's just over it's not the fears, so it's easily affected by the people or something like that. Yeah.
But at least there are redundancy in the data.
Yeah.
On the average, you get a very good quality, right?
Yes.
Yeah, I see.
So that's why we needed to check maybe AI can
Nice.
help to check the fire hotspot. Is the fire hotspot is true or not? Yeah.
Quick
Yeah.
question: how to maintain so many?
Actually, already the connection, this is all for the wireless transport to the data center. So, maintain. Of course, not for the government. just the project for the private
There's a project,
Yeah.
Mon Hey Mon something by
Yeah.
Professor Kanchana. Yeah, it's funded by Asia Connect. They have less than 100 sensor,
Yeah.
but for the maintenance, it's very difficult.
Yeah.
Well, yeah, right.
Actually, Taiwan is
So
small.
now, like we now having the similar project with King College to use the purple air,
Yeah.
a bit more expensive,
Yeah.
but you have to train the local people to maintain it, because
Yeah.
in the project they never have this maintenance funding. So now with this project that we are having, I ask King College, Martin Worcester, to prepare the money after the project, so the local people that train, they can take care of those. You don't have to fly from London, come over just to just to maintain the
Yeah.
sensor. It make no sense.
Yeah, I just mentioned Taiwan is small, not like the Thailand.
All
Okay.
right. So
Anymore
again, thank you very much, Dr.
you.
Lin. Let's give him another round of applause. So our next presenter is Dr. Addison.
Oh, he can tell about the maintenance.
Oh, good.
Can I use my PC? Front? Can I use my PCs, right? Oh, HDMI, okay. All right. Okay, so many equipment. Okay, good morning. My name is Addison Lersin Saptavi. I'm from Interlab AIT. Oh, I need to do this mic. Okay. Yeah, so we are still talking about air pollution, and also this is kind of a variant projects from the CHMON that Dr. Chai mentioned. So in this talk, I will, my topic is on the air pollution on the move, a study of PM2.5 exposures in urban delivery worker. So this work has been joint work research with many institutions and also with our Interlab research teams, as the name is there. So this work we have been collaborated with the University of Washington, Chiang Mai Ratchapat University, and also Thammasat University. Okay, let's move on. Yeah, we're still in talking about the air pollution, and then as we know, so we have talking about that the PM2.5 is a main killer for this crisis. So I just grabbing some issues on the newspapers about the health effect. So now you can see that the air pollution crisis has been going on and going in Southeast Asia, and also we also passing to Taiwan as well, unfortunately. So yeah, looking to some stats, like some people on the health effects, right? Like more than like a million people in Thailand, we have been sorting for the treatment for the disease related to the air pollution. So we just looking to the statistic from 2023, so like only the first 9 weeks, about 1.3 million people are sorting for the treatment for the treatment for air pollution sickness. And then in 2024, it's been significant increasing, like about 1.6 million people have been looking for that. So Actually, the crisis it's been going on and then mostly on it happened during the dry season of Thailand, and then to be starting from December to April. So, and looking for more details about the air pollution levels in Thailand. So in Taiwan, we have seen that the air pollution is about below at about 30, 40, right? But this is like how Thailand look like. So we have been on the x-axis. It has been the average, daily average or AQI from in 2023. So I kept the data from the two air quality stations, one in Dindang in downtown Bangkok, and another one in Chiang Mai at Yuparat School. As you can see, so on the minimum one, we got about 25 to 30. Is it that much? But during the dry seasons, starting from December to April, so in Chiang Mai, it's pretty bad. So we can see that the average is going up, rising up to 240 microgram per cubic meters. Looking a bit more detail, so we have been have the question like how many days that we consider have a good day and bad days in Thailand and especially for Bangkok and Chiang Mai. So this is some a reference index from the PCD, our Pollution Control Department. It also relies to the US and the news rule of US EPA as well. So the color showing some kind of indicators of the air quality index, like blue, green, as you can see now. So yeah, expect. So Chiang Mai have the pretty much in terms of a very bad quality days, but also good for Chiang Mai people as well. But they still have some chance to get some kind of a good days in terms of that. However, if I just my assumption, I try to making some kind of between bad and good. So this is a borderline. I put it up like if the orange and red days we consider as unhealthy days, and then the rest is we consider as quite okay days. So surprisingly, so both Chiang Mai and Bangkok, they're quite a same amount of day, about 96 days, that been considered in terms of a bad day, and then the rest has been, the air pollution is okay in our term. So that been statistic like about 74% of the day of the years, we Bangkok people and Chiang Mai people, we got about in considered as a good day. And then we left about 26 days, which is about 3-4 months that been facing the air pollution crisis. However, so this is some kind of a background from our research in this work. However, so on those stations, we have been capturing for being overall areas of the Bangkok and of the countries, but we still have to thinking about this kind of people, like some frontline worker people who have been working for a long exposures on the street and outdoor, like some Grab rider, construction workers, or street food vendors. So they have been less chance for the medical checkup. They don't know. They don't even know how bad of their health. And also most of these people have been very close to the pollution source, like very old trucks or buses, and also some kind of industrial areas that have been facing for a long exposure. So in nowadays, in Bangkok and also in Chiang Mai, we have government try to push a lot of policies like working from homes or low emission zones, and also for the kids on schools, they have been closing as well during a peak of the PM2.5 day. However, these vulnerable groups has been counted on that policy. And that is the reason why we try to, in this research, we try to analyze and try to understand how much actual exposure of these people has been consumed over the years. So as Dr. Chai mentioned, so we have been, this is we try to benefit from our platforms funded by many funders, including Asia Connect as well. And then this is all list of our research partner. So in our platforms, we call the CHMON. We develop a low-cost sensors, similar to the Taiwan's as well. So our cost is about $300. And then we are using the benefit from the rent networks as well for hosting the server and for visualizations and some kind of services for that. So we have been successful with many partners, and then I saw many faces here, like has been joined in these projects as well. In Philippines, Indonesia, Thailand, Laos. Initially, we have 4 countries, but now we have been expanded more. Like we have somewhere in Nepal as well, Vietnam, and also some in Australia. So we have some note deposited there, but I haven't put it here. So we try to utilize this kind of ideas of the low-cost sensor for this kind of measurement. So initially, so we are starting this project around 2023. So ideally, initially we try to use ours, yes, a sensor box as off the shelf to do the measurement. So the first idea, like we just put them on the motorcycle. But after the first trial, we realized that it doesn't quite practical because most of the rider, if we measure this one, we are not measuring for exposure from the human, but we measure the exposure on the motorcycle itself. So we try to revise our designs, and then we can have some crazy ideas to try to map this sensor on top of the helmet. So very quickly, in about 1 month. But yeah, of course, after the test, you can see that it's quite heavy and thick as well. It's not good for the ergonomics and for the long-term measurement over the days. So finally, then luckily we managed to have the final design in this one. So we separate the box. So one here is our sensor box is very thin and very light, where we put all the sensor there, like PM 2.5 temperatures, humidities, and so on, as you can see from the list here. And then we separate the control box here, while we have the 4G connection module, like SIM card there, and also the GPS as well to track how they move and go on. And then this is ours. Volunteer, our student, tried to make things up, and then he said, okay, so he can, I asked him to stay like for about 3-4 hours over the days, and then, so we finalized, so this kind of a prototype is quite ready for the measurement. Okay, and then this the ours, the architectures of our platform. So here we still using the platform from the CHMON, where we use the visualizations, monitorings, and also data loggings as well. And also, since this measurement is going to be the long-term measurement, so we integrate our system to the live platforms as well for notification. That notification we use for notify the riders and the volunteers that they have been a bad day and good day, so they need to be taking care of their health. But actually, it doesn't work that well, because most of the other one, when they receive the alert, they didn't care because they still have to going out for work. And also another reason why we put the notification is that because we try to track our systems as well, that the IoT sensor is working fine or not. If something be faulty happening on the sensors, so we send notification and then let the rider try to maintenance and then check their node. And this is our insight. So we put, this is the rider that we recruiting them in Bangkok, and then we integrated them like the control box and sensor box on here. So the measurement campaigns focusing on 2 areas, 2 main cities. One is in Chiang Mai and another one is in Bangkok. So we managed to recruit 5 riders from Bangkok and 5 riders from Chiang Mai. And then so the most riders came from Grabs or for food deliveries, and then parcel deliveries, and then ride-sharing services. So the measurements run from November to May. November 2023 to May 24 is about 200 days or 7 months. So the reason is that we want to capture the period before the episode, before the dive season in November, and also during the dive season from December to April, and then we have some time for after the seasons as well. So, and this is some capturing from the spatial distributions, where we are capturing the air pollution exposures on one. This is from 1 riders, and then in a day. So as you can see, we can see some concentration there with so many red spots in the downtown Bangkok and also in Chiang Mai. Even though this is the measurement taking from November, we are still considered as a good day. But we have seen that this is for their exposure is more beyond for from the measurement from the station. So the study area, as I mentioned, we are focusing on Bangkok and Chiang Mai. However, we also try to validate been using our static sensors as well from the Hesmon node, which have been deployed across Bangkok area. So this is our station is here. So this is the same low-cost sensor that we use for the motorcycles, but we try to compare them. Similar to the Chiang Mai as well, we have 3 nodes there, and then we try to validate and then as a baseline compared to our mobile sensor data. And here, it is what we got from over 7 months. So, so the on top is Bangkok, and then below is Chiang Mai. So the spot, the dot here is the daily average from each rider. So each day we have about 5 sample in Bangkok and Chiang Mai. And the solid line here showing the average of the data from our static station. Not surprisingly, we see that so the exposure of those riders is far beyond than the static station that been measured. And that the reason is that we can say that as our assumption is that because they have been very close to the source, like the rider in Bangkok, they have to be following like the buses or that we have a diesel engines that been the main source of the PM 2.5, and also they have to, after interviews, they're also stacking on the traffic junction for the traffic jams as well for a long period of time. That has been causing them for a very high exposure over the days. However, for Chiang Mai, it's really sad for them because you can see that now the exposure has been far beyond up to like 300, which is very bad for their health. Looking for some result, so we spotting that the result from Chiang Mai, the behavior of the PM exposure is a bit slightly different from Bangkok. Mostly from Bangkok, we see that the exposure from the mobile node have been higher beyond the static station. But for Chiang Mai people, we spot that during the peak period, like in April, we see that our static station got more concentrations than the riders. So now the reason that we can say right now is that because when the air pollution is being very maximum, like and then force of the air pollution, so the rider have been ability to move from place to the other, and then they have some kind of winds helping them to release some air, but it's still quite high comparing to the other standard. All right. So looking more closely about and comparing to the standard diet from USCBA, and then USCBA mentioned that 15 micrograms is been a safe limit for the exposure from each day. And as you can see, the borderline is here. Even though the minimums of the exposure from them from all riders is still higher than the minimums the standard. Just only some of them that have been chance to be capture some lower than the 15 microgram for a day. But if you're looking to the maximums and then the medians or the average value, they are way beyond the standard of safe limits already. All right. So another one that we want to show is like this is we are talking about number of days between good day and bad day. This is the result from our mobile sensor. So this is a heat map that we can show. This showing like the distributions of the. This is a zoom in from the April period. So and then each column showing the day, and then for each cell showing the average of the PM concentration for each rider. So we compare to the threshold blue, green, yellows, orange, and then plotting on over this table. And the white space here showing it means that so that rider didn't go for work. So they're taking some kind of a day off for the measurement. So yeah, really not surprisingly, we see that many is a really high concentration, and then we can see that most of the day, especially like February, March, April, most of like the color is been showing red. So looking more stat like from the Bangkok BKK1 riders. So this rider is really been working alcoholic. So over 7 month period, he's only took 3 days off, and then he's working for almost like every day for that. And then considering like the threshold for between bad day and good day, they have been facing about 132 days 32 days for facing for the air pollution, high pollution day, which is cost about almost 70% of their time, working time, have been facing for a very high pollution period. And then similarly to the another riders, so mostly like they got in the bad days on the more than 60%, which is comparing to the static data that I showed from the beginnings, like we have only 24%, 25% for the unhealthy days, but this is like been far beyond from the static stations. So this is really quite early result. We still have a lot of data to be working on. So, but in this talk, I try to summarize and then to have pushing some key takeaways and then open for us to be in a collaborative and discussion. So, some key takeaways that I can be reported right now is like the exposure of outdoor workers is within extremely high pollution, which exceeding the safe limit. So, most of them have been considered as really risky for their health. So at the follow-up, so we have been crucially that we need to ask them to do like kind of a health risk assessment to measure their health and then follow up with medical checkup. So we might suspect that all these people might have some illness or sickness related to the air pollution related. Also, we found that reported air quality data from the static station might not be fully reflected to the actual conditions in the city. Especially for the people who've been more working on the outdoor activities. So that's why we try to convince that the low-cost sensor is still useful. And in this case, because of course we cannot do the stations or the standard equipment for this kind of measurement. So the low-cost sensor is being come to the place and then helping us to do some kind of a fine-grained measurement. And also, I'm keep talking for my every talks like. So the cost of the low-cost sensor is about $300, but $200. $200. But we try to reduce the cost day by day. But the cost from the reference station is cost like, as you know, like $1 million already. So the quality accuracy is still, it's still been discussions like we have some diff that had to be expected. But counting on the benefit that you can use them for many occasions, this is kind of trade-off that we can be balanced. So, all right, I think I want to end up my talk really quickly and then open for the floor for the questions. And before going to the discussion, we have been organizing the NTech conference. So that's the announcement. So this year we are moving our NTech conference to Philippines with the University, the La Salle University in Manila, to be our host. So if you have been student or research work that you have been trying to publish and then please welcome to submit your submission there. So the submission is about in 5 months from now, so you have some time to prepare for your work. All right, thank you, and then questions.
Thank you, Dr. Addison, for the very interesting approach for air quality monitoring, especially like the installation, the helmet with the Grab drivers. We can do that as well in the Philippines. Anyway, questions? There, Douglas, please.
Hello. I'm sure the drivers were very interested in the results also from a personal perspective. Is there like an easy mask that they can wear that will decrease the amount that they breathe in? I mean, obviously they can wear like a standard mask. It would be interesting to get a more high quality mask and then test the same people like a year later to see whether the results that they're getting in year one were the same in year two, because I'm sure the Bangkok Metropolitan Health people must be very interested in, hopefully they're interested in reducing the damage to those people's lungs and breathing systems. So my question really is, for Grab drivers in Bangkok, for example, what's an easy way that they can improve their own personal health?
Yeah, that's been that issue been our tests as well, because we apart from the measurement, also we have some kind of weekly meetings with them. No, bi-weekly, like every 2 weeks. So we meet them. So we try to propose them like many solutions as well, like we giving them some kind of N95, and also a simple one, the thin ones as well. But the answer is that they keep wearing those for some time. But in the actual work, like the 10 hours or 8 hours, so they give up, and then mostly they're dragging off the mask because with the condition that wearing the helmet is really thick already, and then we put another mask on that, so that is kind of really very hard condition for them. So some idea that's coming from the writer is like, if we can develop some mat with the windshield of the helmet, that could be a solution for them. But that kind of thing, like we have some kind of a helmet with the mask on that could be the solution for that. And then that could be my answer for that.
Yeah, just to add for that, the forest firefighter have the same problem. People have a good heart to give them the mask whatsoever, but then even just to walk up to the hill itself in the sun with the mask, like you see in the news that very few of them wear those masks. They have, but with the condition they're working, most unlikely they will take it off sooner or later. Yeah. But they're not talking about the solution. I heard so many years now for Taiwan. That's the government even start up with a company with the electric motorcycle and try to change it, because most of the pollution in Taipei is from motorcycle. So how is that going? I mean, because this have been like for a few years already. They try to replace, I think, 5 million motorcycle. But how is it? How is the project? The effort. How is the effort going now?
Yeah, I forgot the number. Do you know? But I think we push it hard to use to reduce the electric motorcycles. Yeah, but I forget. Yeah, and the government also has some cut. Yeah. Yeah, budgeted cuts and also bus. Yeah.
And just to go back to the Philippines for a moment, it would be very interesting to do this in, say, Manila with the jeepney drivers.
Yeah. We
the diesel, as you know, only too well, I'm sure, the diesel
Right.
Pollution there is terrible. So the same idea in the Philippines would also be very interesting.
Agree. Actually, the most of the engines for the jeepneys in Manila are the surpluses from Japan from several generations ago. So, yeah, it's from Japan. No, just kidding. Yeah. And there's currently, Douglas, there's a movement to move from those type of vehicles to actually electric vehicles.
Yes,
But we know the policy, it takes a while,
Yes,
right?
E-jeepneys, at the e-jeepneys.
Yeah, e-jeepneys, right. But I agree with you. The same concept can be applied in Manila. But Dr. Addison, from a technological perspective, do we see air quality monitors becoming wearables as well in the near future?
Yeah, of course. Like in near future, in our research, we try to reduce the cost and also reduce the size as well. So in the near future, of course, we try to make them be more compact for that, and also, but some kind of hinder for us is been the low cost sensor asset. I need to mention that because we haven't produced the low cost sensor by itself, but we are producing some kind of PCB and the IoT node, and then we gathering the sensor from the market, which choosing the one which is quite a good quality. So now the limitation is that sensor itself still have some kind of a thickness and then some kind of space. But later on, I think like we have some trend try to reducing some size of that. In terms of computer science and engineering, it's not a problem. You can design a really compact one for that. Like even like a smartwatch can be part of them. But we're still waiting for like the electronic size as well for the people who develop the sensor to be a more compact size. And also, to discuss more about the jeepney, we also have been discussion with our partner in the Delasai University that we try to do some kind of measurement exposure on the jeepney size as well. So if hopefully if Asia Connect still continue, somehow we can collaborate in that sense. ISIF.
The ministry can fund it.
Uh, and just to add for the electric vehicle, I think yeah, it's electric vehicle is good, but actually you need to talk to the people like the riders that we have been working to. So it's kind of gonna be the burden cost for them if we force them to buy like EV motorcycle. So even though like motorcycle that they use for work, they still rent it and then loan it for that. They haven't finished their loan. But if you
Taiwan have the model that I'm asking Professor Lin.
yeah.
Because the government buy the government buy the old motorcycle.
Yeah, yeah,
change
that's
to electric half price. They have a startup company from the government side to compete with Honda, Yamaha.
yeah that yeah that's good for Taiwanese people.
Price of the market down. The people can afford it.
For the subsidiary for the electric vehicle? Yeah, in Bangkok or
It's have some benefits for the tax, but for the car engine, like we can see some quite a bit cheaper, like EV car, but for the bicycle, I haven't seen much for that, I think. And also the EV bike is still not allowed to use on the street. It can be used like in locally, like in a village or yeah, that one is the
They have the scooter on the street.
that is not allowed actually.
Not allowed.
Yeah. That.
Not allowed, but nobody touching them.
in Indonesia, we have the government, our government subsidiary for the electric vehicle. And now the electric vehicle, thinking of the scooter, is going around. So many. They give the subsidiary until 25%.
Oh, that's good.
Similar Manila, there are tax incentives, and if you are driving around Manila, there's a vehicle reduction program. You cannot drive on certain days. If you drive an EV, you're exempted from that. So just to encourage more people to get EV vehicles. Douglas?
You know, in Thailand, also in the Philippines, and I'm sure in other countries, if you have, say, a Grab motorcyclist, every second street in Manila or Thailand or Bangkok or Jakarta, you have somebody who can fix that motorbike. So you have the buying of the motorbike is one issue.
Yeah.
But then the man or woman who's driving it, and they have a problem, it's going to take many years before you have the same ecosystem
Yeah.
to fix the problem. That's one of the challenges, I think. It's the same for cars in general, but for somebody who's riding their motorbike hard every day, 10 hours, your ratio of number of days that they're riding is interesting also. They're probably working 7 days a week. So they have to be getting the revenues paid for the motorbike. The motorbike breaks down. At the moment, they can fix it anywhere. There are hundreds of thousands of mechanics in those countries. But it's going to be a long time, I think, before there's the same ecosystem for fixing electric bikes. As a business, not as an individual person driving a motorbike.
Agree.
Okay, so again, thank you very much, Dr. Addison. Let's give you another round of applause. Okay, so welcome back to the second session of Disaster Mitigation Working Group. From air, we're moving to water. So our next presenter is Ms. Wacharapon Soy Jumpa of the Hydroinformatics Institute. So please, you may start your presentation. Thank you.
Okay. Good morning, everyone. Let me introduce myself. My name is Wacharapon Soy Jumpa. I am data analyst from Hydroinformatics Institute. Okay. In my presentation, I will talk about two supporting management preparedness for drought today. Okay. First of all, because I come from Thailand, so I would like to introduce my country. Thailand located between the India Ocean and the Pacific Ocean at from the picture. Tropical climate of Thailand are influenced by monsoon by the country location close to the equator as well as by the monsoon. The seasons of Thailand can generally be divided into 3 seasons and had a factor affecting in each season show that from the picture. In the summer, from mid-February to mid-May. In this season, the transitional period from the northeast monsoon to the southwest monsoon can result in extremely high temperature, especially in April. And the rainy season is between mid-May and mid-October. In this season, the southwest monsoon brings the humid wind from the Indian Ocean, which means that it start rain more in of the Thailand. And the winter is between mid-October and mid-February. In this season, it had affecting by northeast monsoon, bring a cold air from the China come to the northeastern and central of region of Thailand. But northeast monsoon bring with humid wind from the Pacific Ocean, which means that it starts raining more in the south of Thailand. And the annual mean rainfall in Thailand is about 1,500 millimeter. Agriculture is one of the most important economic sector in of Thailand, as it employs approximately 32% of the country labor force. And the main agricultural products are rice, rubber, corn, cassava, sugarcane, fruits, and vegetables. And you can form the picture of water demand. It can be seen that the agricultural sector has the highest water demand. But in the picture of agricultural in irrigated area, it has 83% of agricultural area is located outside of the irrigated area. It means that the most agricultural area depend on the rainfall. Therefore, rainfall during the southwest monsoon is important for agriculture because this is the main factor in the rainy season of Thailand. Okay, and then as everyone know, we are currently in climate change. From the picture, the percentage of rainfall anomaly in Thailand, you can see that the variability of rainfall has been increasing. Normally, Thailand has dry spell period of only 2 weeks in June to July. But in the about 20 years ago, the periods have become longer. The summer is the longer, as the max temperature is increasing. The above factor combine to cause Thailand to be affected by drought for longer and more several times. For example, in the last year in 2024, decreasing of important agricultural products such as oil palm, sugarcane, cassava, rice, fruit tea, especially durian, coconut, and pineapple. And the price of crop is increasing, especially short-lived crop that require high water. When the weather is hot, there is drought, gold is decreasing, result lower yield, vegetable price are therefore increasing. Okay, in this situation of water variability, planning agriculture to suit the available water resource is important for Thailand, an agricultural country. Therefore, it is the objective of this study to analyze area at risk of water shortage for agriculture and apply water balance to adapt in climate change. This is objective for study. So, let's start with the water balance. Water balance is mean the balance between water budget and water demand. For example, of water budget is rainfall, natural water source, non-natural water source, and for example of water demand is agriculture, livestock, consumption, industry, tourism, and preserve the ecosystem. And the purpose of water demand, water balance is to assess the amount of water budget, whether there is sufficient water or not, in order to find water management method and just the balance of water use. Okay, this slide will show about the water balance analysis is divided into 4 steps. 1, evaluate the water budget of the study area. And the step two, evaluate the water balance of the study area. And then check the water balance to see if the available budget is sufficient to meet demand or not. And 4, determine option for managing water. For example, in case when, Okay, for example, in case when accessed water budget is less than water demand, this means that there is not enough water. You may need to find ways to crop, such as to control water requirement by adjusting the crop calendar, reducing the crops, or selecting the crops that require less water. And to analyze the area at risk of water shortage for agriculture with our objective, we use the principle of water demand, water balance analysis. The model that can be used to calculate water balance is the soil water assessment tool or SWOT model. SWOT model is a small watershed to river basin scale model used to simulate the quality and quantity of surface, the groundwater, and predict the environmental impact of the land use, land management practice, and climate change. And to run the model uses the hydrological diversity which constitute the land cover, soil characteristic, and land slope characteristic of unique land use. And the reason we use the SWOT model because this model is a public domain hydrology, and this model can be analyzed agriculture water demand. Okay, this is to analysis of drought index for agriculture. In this study, we use the average number of days the crops representative can tolerate dehydration from research, which is a group into 5 groups that you can see in the table. 1, paddy field is average from rice. Short duration field crop is average from corn. And long duration field crop is average from sugarcane. Fruit is average from orange, and perennial is average from rubber. Okay, now let's move on to the method for analyzing area at risk of water shortage for agriculture. In model setup, we import input data, for example, rainfall, temperature, humidity, then soil map, land use map, and then model will overlay slope soil map and land use to hydrological response unit or HRU. And then run the model. For run the model, in this case, to analyze area at risk of agricultural water shortage, we choose the rainfall in year 2019 because the year is a low average annual rainfall of approximately about 1,200 millimeters, and many agricultural crops were damaged by the drought in this year. And then calibrate model with the runoff and analyze output data. The parameter obtained from running SWOT is water state day, which can indicate the water shortage of the crops. And then classify criteria the water state day in each HRU to drought index or DI, and then analyze to the sub-basin and sub-district boundary by weighting the statistical method. For example, to area at risk of agricultural water shortage from the table, number of the plants can tolerate dehydration. You can see the rice had 8 days to tolerate dehydration. We will divide the criteria for the risk of agricultural water shortage in rice as shown in the picture. When you analyze drought index in each sub-district boundary and then result is 3. It means that the sub-district is low risk agricultural water shortage from the picture example. Okay, this is the area at risk of agricultural water shortage from the result. Almost area of the country, especially in northeastern region, are the moderate to high risk of agricultural water shortage. This indicates that the area may not have enough water resource to support the current type of agriculture. And this is the result from the analysis and compared to the 2019 drought situation. And the left picture is the area at risk of agricultural water shortage from report drought disaster situation. There were 32 sub-districts. And the example drought impact in 2019 in report said that the Mekong River still die. Chiang Rai Khon is starting to die. This is example. And okay. And the right picture is an area at risk of agricultural water shortage from analysis. It will be seen that the most drought area of agriculture are consistent with the actual situation. And finally, this is the conclusion in my study. This idea of modeling water balance by using historical rainfall data represents that crop production in situation of risk of water shortage could be detrimental. And this model can be created to prevent future damage because HII has a rainfall forecast. And since we have a rainfall forecast, we can use the model input data for the water budget as a rainfall forecast. If the model run result in a risk of water shortage for crops exceeding the number of days that plants can tolerate dehydration, we can decide whether we should cultivate or abstain from cultivation. Thank you for your attention.
Thank you, Ms. Wacharapon. So any questions from the floor? Yes, sir.
Since you have a lot of the reservoirs, do these connection once the nose is short of the rainfall, so you can support from other reservoirs? Yeah,
Reservoir,
connection.
Yes,
Yep.
yes. In this the model we can input the reservoir data management into the model.
Yeah. I mean, if the drought occurs in the south, so you can if any connection from other reservoirs, rainfall, the water support connection. In Taiwan's case, we have this kind of design from the northern reservoirs to the TSMC actually need a lot of water cooling down. So yeah, so in Hsinchu, in Taipei is in the Shimen reservoirs support to the south Hsinchu reservoirs once the drought periods.
Excuse me. And actually, my organization is in the process that we're working on it with all the dam reservoir that connect together and manage together. That's what we have done. And another, actually, my colleague, the one that not in the room like now, he's doing his PhD on that, how to work with management on a 3 reservoir in one sub-district. And then we expand in the big picture in the watershed area of Kong River Basin, Ing River Basin. So how to manage 23 dams among this watershed area. That's what I focus on like now.
It's very good that you can analyse the whole country, so that's very interesting to see that the whole of Thailand is covered in the study, so that's very good. And I understand that it's rainfall that you are looking at primarily as part of the water budget. I was interested in one part of your slide, though, where you said about the Mekong River is still low. So my question is that issue to do with rainfall, or is that issue to do with other upstream developments? Because my understanding is that other countries, you know, Cambodia, Laos, Thailand are all having a challenge because of the damming of the Mekong River. So I was interested, are the problems caused by rain, or are the problems in the Mekong caused by other issues? Is there a sort of a general answer to that, or do you?
I also can help.
Is that a difficult question? Sorry, my apologies. I thought you might.
I forgot. My name is Roy Boon once again. I'm a director of HII
Yes,
Thailand. Actually, what we have done, we know that and we realize that we have enough water. But it depends on how you manage. On the side of the Kong River Basin, we have been working with a community-based solution. They can manage without heavy flood, without drought. And they can expand from one village to 5 sub-districts. Even we faced the problem of the big flood last year. They had no problem at all. And they have enough water for all year long, for quite long time already. It depends on, that's why we call water balance. You balance and you have information.
Yes, I understand.
To
Yes.
manage.
I mean, it's interesting because I was a couple of years ago in Vietnam at the delta of the Mekong River, and they've got some challenges, I think, which I'm sure you know about, you know, at where the Mekong River is entering the sea. The water flow is reducing, you know, there's seawater is starting to come in. This is really a problem that is affecting many different countries, I think, in that particular area, is my understanding.
For me, I think that if we don't have a big dam in China, maybe we have a big flood. We have a big flood.
Actually, you have to understand that so many dams in Laos. Okay? Even in Laos, they have problems because another company not release water. So some dams have less water. So because they want to sell electric, the grid, for the whole ASEAN, something like that. So they built a lot of.
International problem because, you know, if you go to the Aswan Dam in Egypt or if the Hoover Dam in the USA, they've all had sort of issues over the years. So, but anyway, thank you very much indeed. It's very interesting.
Just follow up the question from the dam from China. So I think we heard some news like if management of the dam in China, if they push some water back down to the south, so how could our capacity in Thailand and Mekong region, can we manage that thing for the flooding and so on? Do we have any kind of policy mitigation for that? But I'm not sure that this is like rumors, news or not, but we heard some from the news, like, yeah.
I think the answer should come from MRC. But anyway, from my opinion, I think that it depends on if you have information on your side, you can manage well. And what we have been working with La PDR, and we try to work closely with China, so we can like get more information, and if we work closely with MRC, we can share the information also on our side. And anyway, we also setting up our telemetry station on Lao side and then Thai side to manage for disaster management. And I just 2-3 weeks ago, right? A month ago that we went to La PDR. We have been working with La PDR for more than 10 years. And like now we will set the network, people network, local people network to work together along the side of the border side of both sides, so we can manage water well along the way. And we have proved that with our information, Lao, for disaster management, for they know before disaster happen. Based on the information, we setting up telemetry station. That's how we work from the bottom-up approach. If we wait for top-down, it's not on time.
Okay, may I? Okay, I fully understand and the discussion what Dr. Chai and Dr. Sarpon said, because I was in Laos and Vientiane from 2018 to 2021, and the water flow of Mekong is very important. Yes, and there is a international organization to manage manage the Mekong River water. Well, I know an officer from the Ministry of Agriculture and Forestry and Fisheries is seconded to the office in Vientiane. I don't remember the real name. It was Mekong River Commission, like that. Yeah. Yeah. So anyway, water is a very important factor for agriculture production. And my question for her is, yes, my question for her is, yes, it is very interesting and quite general. I think it is quite general research. And how do you use the outcome, for example, drought index to the agriculture production? Well, it is quite well. Well, of course, the rainfall differs every year, and in some year, the drought index is not very important, and some year. Well, it is important, and it depends on the area. For example, northeast and Thai has a larger problem. So, how do you use the outcome of the research to the agriculture production?
Okay, how to use? Okay, example to use the drought index to the agricultural area. We can input the in the present we have the rainfall forecast in the many model. You can input the rainfall forecast into the model and can be the generate the area at risk of water shortage. This output. You can use the rainfall forecast input in the model. Okay.
Probably in relation to what Kame-san is asking, for example, you've mentioned about crop rotation.
Yes.
So if it is predicted that there will be drought, do you change the next crop that will planted? Or do you change the type of rice that will be planted, less dependent on water? Do you implement such strategies?
ใช้กับเกษตรยังไงถูกไหมคะโอเคโอเคได้พี่ปุ้ยก็ได้
Like we work with a national farmer council. And like if we know that this year we'll have a big flood in the middle of the year, they will grow rice first, and then so they will save and the government does not have to pay. And then when we transfer the information to them, they will know, and we also let them decide for their crop calendar, and they can transfer the information in particular area by themselves with the information of the historical record of the rainfall, and then for the forecasting, they will know what they need to do in particular area based on our information. We have done with 20 provinces, especially in the northeastern of Thailand.
Yeah.
Thank you very much.
We support you because Philippines' largest importer of rice. We import rice from Thailand. Okay, thank you so much. So
Thank you.
let's give her a round of applause again. Thank you. So from lack of water, we go to more water, oversupply of water. So next presentation is from Dr. Thirapul Charyonsuk.
Good morning, everyone. Again, thank you for introducing myself. So my name is Thirapul Charyonsuk from Hydro Informatics Institute. Today, I would like to present about the integrating hydro informatics for flood disaster mitigation. First, I would like to the introduction hydro informatics in Thailand. After greater flood in 2011, we think about that what the problem, why Thailand have the flood, big flood in that area, and everywhere in Bangkok is under the water. I just graduated master student in 2011, and then I back to hometown in the north because I cannot work in here. So we think about in 2011 we lacking of the tool for the real-time flood monitoring and predictive modeling. And the deficient support system for flood risk management and disaster response. So I think at that time we did not have it. Then 2012, I developed the National Hydro Informatics Data Center, or NHC, in the Thailand. We collaborate with the 53rd agency in Thailand now, but actually in the first period, maybe 10 agency, and then we try to collaborate with them. And we have 435 data set related about the water, not only the water, if rainfall data, saline nitrogen, water quality, everything. And also from the reservoir from the Royal Irrigation Department or Royal Rainmaker. So after we collect the data, we also developed the flood forecasting system in 2012. But in the first period, we focused in the Chao Phraya River Basin because it's like the heart of the Thailand. We have the capital city and economy quite important. And then the flood forecasting system is kind of the river flood forecasting system. We focus only the main river, and we warning at each key station to manage water. And after 2012, we extend to the Chi Moon flood forecasting system in the northeast of the region of the Thailand, and then we extend to eastern flood and west and south. So after the system cover around 70% of the Thailand, and we try to recalibrate again because the information is still going. That's why we try to recalibrate and update the information again. For the system, we have in the forecasting system, we have the 4 components. You can see in the data source, this is the first component about the data come from. We use the real-time data and forecast data. For the real-time data, for my own office, we have the water level and rainfall. For the discharge, we use from the Royal Irrigation Department. They provide the discharge real-time data to the NHC. That's why we can use the discharge from them. And also the EGAT or Thailand Meteorological Department also use the rainfall to input to the model in the real time. But for forecast, we use only rainfall prediction from the high, or because rainfall prediction, we use the WAFROM, is a weather research forecast covering regional ocean model to prediction. And then we collect the data from the NHC or the Hydroinformatics Institute, Hydroinformatics, to the data management in the second company. And after we import to the data management component, we have the pre-processing because every agency, they have their own format. For the example, some agency, they use the CSV format, Excel format, and the unit also different. That's why we should have pre-processing before. And some of data is not good quality. We should clean before you. If for the example, we have the spike. That's why we have the threshold to clean up first. And then after we clean up, we send to the third component, model management. And the model we will run start from the rainfall runoff model to the inland flood model. And after that, we send to the data management again, because to store the prediction data. And finally, we visualize in the interface management with the map, graph, and table or animation flood animation. For the flood forecasting system, we operate every day. Now operation still developed 2012 until now. We also support the Thai government every day. And if we have some issue, some situation, for the example, last year, we also went to discuss with the Thai government in the big room with many agencies to discuss about the how it prediction. And because Thailand, we have more 10 water agency. That's why we should have the discuss in only one room and make a decision. After that, we provide the prediction data to the Thai government. The Thai government will decision how to do. And for this, show the key situation we use to prediction. For this, if you see in the graph in here, we can show the hindcast before time of forecast 7 days, and we can predict 7 days ahead. And in this system, we also use the data accumulation to reduce the uncertainty of the prediction. And if some issue in the lowland area, we also have the 1D, 2D copper flood model to prepare the flood map or the flood risk area. So after that, when we predict everything, we will visualize only one map. Because if to understand the left-hand side, we show the warning from the monitoring. I mean that from the real time. If the data real time is above the threshold, we set they will warning. At the right-hand side, we warning from the prediction, including the storm track, rainfall prediction, storm surge, flash flood forecasting, flood intrusion, and down monitoring also. And this picture show from the track of storm come to the Thailand. And if we warning everything, you can see the warning from monitor and warning from the forecast in the left and right. And this website we can focus in the basin or the province too. So this is some situation in Ubon Ratana Thani, August to October 2019. The Thai government assigned to high to predict about when the water discharge or the flood decrease. because in the Chi Moon we have like a long flood, more than 1 month. But flood forecasting system we can do, but maybe have error because when we operate every day, we will accumulate error from the system. So if you see the graph, the blue point is the observation. The black color is from the simulated model we predict. And the orange point and red point is a low bank level and high bank level from the M7 station in the Moon River. So this is we prediction, but in the real situation, the discharge or the water level is decreased so early because they have the pumping station in the downstream to pump from the Moon River to the Mekong River directly. So that's why the prediction is accuracy around 70% in this situation. And then some situation in the Yom River in the northern part of the Thailand, 8 to 10 July 2021. So we have the heavy rainfall in the upstream, and we can predict 7-day lead time in here. And then we send to the Thai government to make the decision and send to the local communication. We work with them. So after here, only the river flood forecasting system, we focus in the main river. We also have another system to like the short period, for the example, flash flood forecasting system. So this is a public storm in 2019, and you can see the track of the storm public in each day. We will warning for flash flood rich area in the polygon, in the sub-district area, in the 3 December, 4 December, and 5 December. But this event public storm is not only the flash flood. We have the storm surge in the southern part of Thailand too. We also use the storm surge system to prediction with the to predict about the where if they have the storm meet the inland, and also we want to predict about the total sea water level in here. And for the accuracy, 1 day ahead only 70%, and then decrease respective. So not only the storm surge. If you see in the Gulf of the Thailand in the red color, this storm is affect to the Gulf of Thailand in here. So this is the Chao Phraya River. The Chao Phraya River is an important river because in Bangkok we use the fresh water in the Chao Phraya to pumping to the drinking water. But in this situation, we have the problem about the storm surge. It came to the southern part, but affect to in the Chao Phraya River too. We have the saline intrusion in the Chao Phraya River, and we also have the prediction, and we tell the MWA they provide the drinking water to the Bangkok, and for the accuracy around 70%, and then decrease respectively. So for the challenges in the system for forecasting, the limited about the tool or for the real-time flood monitoring and prediction model, and also model uncertainty. We should improve. And now, everyone know about the climate change impact. So that's why we should work hard. In the future, we will use the AI for the predict flood modeling in the real-time flood forecast and hybrid flood forecasting system. Because the machine learning or AI, we use the training from the historical data. But if in the future we have the extreme event, I think a physical model also important too. That's why we should have the hybrid. We can switch to, we can use the machine learning prediction and physical flood model. And also integrate the EO observation data to impact-based analysis. Thank you for attention.
All right, thank you so much. Now we open the floor for questions.
This is Prashant from Nepal Rain, and this is very good presentation. But I think you are not implemented yet. You are saying that the future project is AI or something like that, right? So, but how do you monitoring right now the flood? You are saying that flood monitoring, right? So,
Yes, yes.
in
I
terms
think,
of communication, or
yeah, yeah. I think the ladies guy, she can talk with me more. But we also have the website to like the real time monitoring. We have for this, but I can show you Thai water the date. We also have the rainfall many agency. Now I think in Thailand we have the rainfall station more than 3,000 stations. Yes, and also water level more than 2,000 stations. Because we fought to every agency, right? In high, I think maybe we have a 1,000 stations, 700 in the rainfall station and 400 for the water station. And we use that to monitor and also use the prediction from the rainfall from the Thai Meteorology Department and also high to make the decision. Because sometimes the rainfall is different. Rainfall prediction, rainfall prediction is different. They tell here heavy rainfall in this area, but high predict in this area so high. So we will make the decision together to how to do it in the big room. And after that, we will announce. But high, we did not have the law about the announcement. That's why we just support to the Thai government, like the information. Okay, we have the definition how it's going. Yes. Okay, but I'm not sure we can open it or not. Yeah, so, because in Denmark I cannot open it. Yes. Yes. For the example now. English. Okay. Okay. Yeah. Sorry. Yeah, but for the example, here the 24 rainfall maps and it's a real time. Yes, and you can see in here weather rainfall. For the example, we saw the rainfall data first. Here. Yes, please go ahead.
So how it's communicated, the whole station, how it's communicated? Is it communicated by the LTE or something like that, the communication model?
If I remember, I'm maybe not correct answer. We use the API to connect from the their agency.
Is telemetry?
Yeah.
Yes, yeah.
I think 4G.
4G.
By the AIS.
So every station has a very good power. That means.
Yep. Yes. Sure.
Because my concern is more in power too. Sometimes the
fifth generation.
Oh, okay.
Yes, definitely.
Developed for narrow.
What type of power actually? It's a solar power or what? Oh, okay.
Both.
Okay.
If I remember for the high, we have
okay.
the solar, and we have the battery
Okay,
inside.
got it. All right.
Yeah. You can ask him. I'm modeling.
By
We use the WAF from. Yeah, WAF from and WAF if the assumption we think about ocean also have effect to the climate. That's why we have the regional ocean model, like the copper between weather and ocean. Yes.
Yeah, the telemetry station is have use battery to the main power. If you have no suns, is have use battery in 7 or 10 days. Yeah.
2-3 weeks now. 2 weeks, 2-3 weeks. Just like a car, like vehicle battery.
Yes.
Not asking for the connectivity anyway. Okay, I'm quite interesting about the warning system. So the question is that because as I understand, by the way, I'm Addison from AIT. HII doesn't have any responsibility to warn the people, right? But you let to the government like a war room to warn. But my question is that what kind of period that you give the governments and then the people know beforehand?
Oh, that's a good
Before
question.
the flood.
So actually, I can say we have the monitoring group, the lady, the pink shirt, because first of all, we monitoring every day, and we follow up the storm if coming. I think last time, if I remember, but I did not stay a long time, 4 days or 1 week, we just, okay, we found, okay, the storm is coming. We just check everything about the capacity of reservoir, water level, everything. Should be to decrease the volume in the reservoir or not. And then we give, I would say, we give the information to them because we cannot push everything. Yep. And then I think 7 days, and after storm is coming, because the storm is also prediction of the storm have uncertainty. We should update initial condition every day or every hour if we can do. So we follow that route to warning, to give the information to the Thai government. So I think if correct answer, I'm not quite sure.
Yeah, I think, you answer my question, like you provide them like
Yep,
7 days
7 days,
beforehand, but
yes.
the final judgment and final announcement is not in your hands.
No.
Yeah, it's the government, so I understand that. Yeah, thank
Yes.
you.
Right. Now, of course, in your model, you can predict the flood level. But I'm also interested, do you also monitor how quickly the flood recedes? How quickly it comes down?
Oh,
Because I think it can say a lot about, let's say, the drainage system, how silted the river system is, et cetera, et cetera.
Yep. Thank you for the good suggestion, but we didn't talk about that. Not now, but I think for the recovery, I would say the recovery, I think we have, but I didn't know. I didn't know a lot that because I'm flood modeler. So we forgot in the accuracy. Yep.
All right. Oh, this is the water level monitoring system?
Yes.
Yeah.
You can see the battery.
Oh, yeah.
Yeah, this is water level. Yep.
Yeah.
Yep.
I think, well, for us in the Philippines, aside from this, related to the question earlier, we also deployed flood early warning system. So when it is expected that flood will happen, a siren will alerting the community to go to a higher place. It can be automatically triggered by the machine itself or manually triggered from remote by our Met agency because we don't, the local government doesn't want the responsibility of turning it on and then nothing happens, right? So it will only cause panic to the community. So that's one thing we do in coordination with our agency as well.
Yeah, there's a community warning system that they're using media box, I think, that to communicate to send the information. No more, I don't know that, but or water level to warn when the water level coming up too quick.
Actually, like now we set a people network that they can get through our information. They can get through our information. Is 19 network, the area that have a disaster a lot, so they can warn, and then not just warning, but they also can help to evacuate, and then not just that, for like a restructure in this area to make it like relief of flood and drought in the area.
Okay, any other question? If none, again, let's give him another round of applause. Thank you so much. All right, so from water, we go to fire.
Oh, no, we have to talk more on that. It's not simply like that. No, it's not simply like that. Sorry. Okay. Back to fire and smoke. Okay. Well, wind is the one. That's what not simply like that because of the wind. Wind will carry smoke, and what kind of smoke? Okay, we always pretend that the smoke is just like from peat fire. Peat fire like Indonesia, yes, but the dry forest, the smoke have a different property, and it's dispersed. So it's not come like you can see from the satellite, or you can see from your eyes, as Basuki, that if the smoke come from the peat fires, totally different. It's a different story, and the wind cannot just disperse those. But that is many things that have to understand, and then when we understand the property, and we can see it in different perspective. But most of the people, they don't look at like that. So, yeah. But this is just the update. So I put so many local up there because those are the agency or the people that related to this update. Okay. So we have different. I'll go along. This is the topic that I will update. So we started with the NASA firms. They had, but not launched yet. This is just the back end that you can see that they have map2/. So it's still in the testing. That is a request for a few years, but they don't have a budget to do it. But now, last year, Diane Davy, the manager of NASA Lands, which is NASA firm is under, sent me this link to test it out, because we would like to see the analysis on one system. Don't have to use a different system to analyze this, which is much easier, and you can change, overlay with different kind of information that related to forest fire, the burn area, the hotspot. So you can see, and you can change the color. You can do. I would request more, because the parallel we have to use the FAO system to see, but it's based on the same data, same from NASA data. The problem is that they service for NASA firm to the whole globe. So if they put everything, their server cannot handle it. So that's why even the FAO server, you can upload the shapefile wherever you want and do a simple analysis. But for NASA, they do not allow that, because it's too many people put the request. The server will crash. So they're not doing that. Okay, but this is a good one that probably will launch soon. But for now, not yet. It will help a lot to see the movement of the fire, because the request has been, I think, maybe 5 years ago, to see the behavior of the people that where they light the fire, and they will ignite those fire anyway. So with the burn area data, which is like 25 years, and the active fire product for 25 years, we can compare and see, and perhaps we understand and try to prevent those fire to happen. So you can go to the link and then try that. And then another one, this is started 5-6 years ago because of the NASA system deliver the information 2 to 3 hour latency. So for the operation, daily operation is very quite a bit difficult because the satellite is near real time, so it's take long time. And to do the forest fire suppression or control, you need to do it as quick as possible. Like for example, French, they do it they don't use satellite, which is like, what? Why don't you use it to build it? And then, no, we use plane. Okay, they have a plane, 2 planes flying all the time, which one they call dash, which will attack the fire that they detected by the plane, 737 Boeing, within 10 minutes, and then the ground people go in. So the satellite will not answer that question for them. That's why French civil protection, they're using the plane instead. But the problem is that the cost. The operation cost is like unimaginably a lot, which is, that's also the problem. But we also have the system that to do the fire danger rating system that ASEAN using it since after the big forest fire in 1997-98 that happened in Indonesia, that emit still #1 that put out the fire emission. Even the Black Friday not overtake that yet. Or maybe if they calculated the Canadian one 2 years ago, that's also like 20 million hectare. But maybe the Indonesian one still top that because the data is off the chart. And that's why after that, the Canadian Forest Service support ASEAN to calibrate the fire danger rating system in 2002 to 2004, and then it's online 2004. Ever since, BMKG of Indonesia, the Met Department, they're doing this, but the mandate they didn't change it. The mandate still be at the Malaysian Met Department. So the Malaysian is the one. ASMC, that you can see from the website, no, they cannot do anything, but they also they use the data from the Malaysian Met Department to issue or to make the web map server look nice one. So the Singapore, they can do much better. But I had a chance to visit them, and with the team from the King College, that and learn that their fire emission, that they put out information on the web for the whole ASEAN, ASMC. They also saying that the product did not, they didn't do the calibration and validation yet. So it's still from the model itself, which is the accuracy they don't know. Okay, that's they try to do it with the ECMWF, Copernicus Atmospheric Monitoring Service system, to do the calibration and get the most accurate possible for the people to use, but still going on because the boss there saying no, that means okay, no, just like really, but a lot of people using your information, but they didn't say the accuracy. But for Thailand, we have different kind, the same system, fire danger rating system, but we have different kind of vegetation, so we need to recalibrate it. The guy who did it for ASEAN, Bill de Groot, before he retired, he's asking when Thailand will do it, because Thailand signed the transboundary haze, I think 2006 or 2000, I don't know, yeah, 2004, 2006, but didn't do it. So I just try to convince the people that know the code and, to try to do the calibration from the weather data that we can have a hand on. But the problem, when you go check into the field, nobody using it because it's wrong. It's totally wrong. It's like, what, really? You know, this is a peer review paper. No, but no, in the field, no. So, and then I got the equipment from Canada, the FTS, that they doing the forest for 5 weather station, telemetry station, but 5 weather, which can measure the humidity of the field, the temperature of the field, and all other parameter related. And at the station, our threshold show that it's red, but it's still green, and everything is not that. So like, wow, how? Then okay. Then I start to communicate with the Canadian Forest Service, the original, and asking Natalie and Mike Wharton that you are the #1 of the world now. Can you help? And they said they need the weather data. So 5 years ago, 6 years ago, wait, let's see, maybe you have that, maybe not. That the official paper from the Royal Forest Department to get the request to get 30 years data from the Met Department, the Royal Thai Met Department. But it's cost 24 million baht, and we have no money. So it has to went through the committee to waive that cost. And then finally did, and we sent 2 years ago, we sent the data to Canadian Forest Service to do the calibration for us. And they got a new set of threshold, which we are testing this fire season, and we probably have to adjust it because you need to check it in the field to do the validation and calibration. And we will have discussion after this fire season, which is probably in May. We will try to do that. And the other one is, well, maybe, yeah, okay. Just this first. And so now they have this and changing to this, okay? It's up to the ministry level, not only the department now. We're trying to push that so you don't have to argue, just like use this for the ministry, that's much better. Because, and then I'm mixing up with the other, these students, this from France. So they helping on, they came for the internship last year. I took them, 3 of them from the computer engineering from Nong University. And I asked them to do the quick one that we had the request from NOAA. It's mixing up this one, wait, sorry. The second one, that the NOAA one that can receive faster active fire, which they built another system in the NOAA NASDIS that service for the U.S. Forest Service. So we now can have the same, I don't know how they do it, they can make it within 35 and 40 minutes after the satellite overpass Thailand. And we have it, and those students, 3 of them, Morgan, Doran, and Shill, built the system, which is look like this is the one that Windfetch Loader built it for us and extended when we had the APAN in Nepal. I learned that Nepal is still using firm, so it's a little bit slow under EasyMod. So I asked, put the request to Windfetch Loader to build another one extended to Nepal. And now I hopefully still using it, Sunta Sharma with EasyMod using this data for Nepal. And we received this a bit faster, within 35 to 40 minutes. And now with the student, we built this tool for the service of, actually for the Department of National Park, Wildlife and Plant Conservation. But because they have so many experts, they're not using this, okay? So currently, the Royal Forest Department and the local NGO are using this. So it's just simple, but we try to display the information as soon as possible. And then we classify down to the purpose is at the end for the district to use it, because the Royal Forest Department already transferred all the mandate and budget to the local administration. But the problem still, we use a Uninet server, which is a little bit slow connection. So I need to fix that to get it faster. But until then, if not many people using this, so we don't need to do that. But now it's extended for Lao PDR and the Cambodian, the Department of Forestry of both countries. We are building it for them, extended for them to use. But still, they want the number. It's a different purpose. This is for the fire suppression, because you can get data as soon as possible. But they want the number to show their prime minister, something like that. And that can be one of the, for Lao, for example, the one who doing everything for the forest department, he can do it using this data as well. But the problem is that they only use for Thailand, use only one satellite, but here it's 3 satellites with the same sensors, which come like 25 to 30 minutes apart. So the point is not to count the number. The point is to do the fire control better. So different purpose. So, but they can also use this data if they would like to. So like I said here, the unfortunate that the DNP, the Department of National Park, they decide not to use this, but the Royal Forest Department use it every day because we have the 3 satellites, so some of the active fire not detected. So they do suppression near real time. When they see this, they try to go in deep in the forest. So it's good that they're using it for daily operation. So this is the example that they're using in the, they call it, for Royal Forest Department, the name is Suan Na, which is like the front post up north for the 17 provinces that they are working on. So they're using this. And they also use Sentinel, because Sentinel come every 5 days. So they want to see the active fire is on the old burning area or not. So they can plan the operation, because they don't have many firefighters. So they have to pick which area that they have to go. If it's close to the burn area, then you could wait. You can plan that it might burn to the old burn area. We call it black area. So it's not spread. So you can mobilize the troop to the new one that might be more damaged than it's supposed. I mean, the one that near the burn area. So this is the example, and then they checked it. When they see the hotspot, they use the drone, the thermal camera, to fly over and check how to plan before they attack, try to suppress the fire. So this is like the dairy operation. They're doing this every day. Some area you have to walk for a day, with the 4-wheel drive truck and then motorcycle, then walk. Okay. So this is the one that just the firm, they would like to document something, so they asked me to help writing this. So this is just like the history of what we are using that data for in the past, I don't know, almost 20 years now. And community work with fire and water. Usually when they do integrated forest fire, integrated forest management, they do only community-based fire management. But because I work for the HII as well, hydroinformatics, and we have this community water management, so it's might be the time, or it should be the time, that when you're doing anything regarding the community, you do both fire and water together. So this is just published with Professor Bambang in Indonesia. And that's the Bambang. See, I look smaller. It's good. I love when I see Bambang, because Bambang is very big. Okay, so we just had this for Korean. They have a matching matching fund with the ASEAN Secretariat that they're doing forest fire for 4 countries. Unfortunately, Thailand not participate, which is strange. But it's Myanmar, Cambodia, Laos, and Vietnam. So we did the symposium for them, managed it, well, helped them set up everything, and we have a discussion. Still, ASEAN Secretariat there, because they also pay half of the funding. They couldn't do anything. The problem is there's changing structure a lot. For example, in Indonesia now, they separate from 1 department into 2. So if you're talking about the smoke, the haze, 1 department will take care of that. The other department change to only forest fire control. So Isra just, text me. Don't ask me about smoke anymore. I'm not that part of it anymore. I'm just the fire control. So, okay. But this is something that I ask ASEAN Secretariat to change, because when they have a meeting, it's usually mean nothing because the people that really work is not involved. And they said, well, why don't you just check that if they change it, you change the people to come to the meeting instead, because you will get the people that are not responsible on what you're talking about. So but they said they couldn't do anything much because it's depend on the country. So too bad. Then the update that we conduct the Department of National Park and work with the army, that we train for the Cambodian army, the border army, for the fire suppression. So in the future, hopefully, they could could help in terms of the fire suppression near the border of Thailand and Cambodia. Okay. That's the general on the left. Yeah, this guy. I just like, who the heck is this? Not going. I mean, supposed to sit there, not on the side. Like, no, I'm not. I'm just sitting here. There's a general. So, okay. And then we also have up there the 3rd time now that we're conduct the fire suppression for AFOCO, the Korean agency that having 15-member country, that ASEAN, including Mongolia, Bhutan, Kazakhstan, Kyrgyzstan, that doing the training, but they just signed the agreement with French civil protection. So we're doing this suppression training for member country of AFOCO and have the higher education. So any forester that's working in the forest fire can have the higher education in Korean or in France. Most of the time they would like to go to France for master and PhD. And they will support to get some equipment, hopefully. Okay. That's the update. This has just happened last month. And another one is for the forest fire is in the group of the global fire situation that me and Bambang are helping them to assess the situation each year. But we just it happened last year. So this year also, but because of the fire in Siberia and in China, so the report this year will focus on that, and some in Southern Asia, South Asia also happened, but nobody really can explain that. So the focus will be for China and Russia instead. And lacking that we need to develop the calibrate. Like I said, you have so many models to run, but one thing that you want to see, the fire mission to good one, is called wildfire. But nobody running that. So you can see it's combined between smoke and fire behavior. So it can tell you much more instead of WAPCAM. You were talking about forest fire, not the urban one. The separate one. And we need to get the more efficient decision supporting system And FIUSA now have a Sentinel hub. So we would like FIUSA to select Thailand as the first country in ASEAN to expand it, to test it out, all the whatever gonna happen, that please, Thailand, Thailand. And we need to understand about fire weather, because people are not talking about that. They're talking about the weather, but we also have fire weather. So it's different. And then we have to understand the smoke haze behavior. The most important, we have to understand the human behavior. Okay, that's because 100% of the fire in ASEAN is human ignition. So human is the cause. So if you can understand, the most difficult thing to understand people behavior. Science is nothing, Science you can, but people, you can change all the time. So that's need the social science side. I already asked, but I don't know that they're gonna get involved or not. King College University, that they have a social science department that please come and then do some studies, then we can understand the behavior of the people more. And the free access, this is would be very benefit if people can have. We have this system, and then try to push a focal. And Christie, but they already talk with Christie Banchung Cho. They already talk to have this system, because the Korean government will be the one who pay, so it's supposed to be in Korean. I insist that, but I don't know that they will believe you or not. But it's the concept note I wrote for them, because I would like to see this. So it's just like, okay, very happy to do it. But this is 3 years already that they're not pushing it. So in conclusion, it's the same thing always. I usually say this, that's it's not climate change anymore. It's climate crisis and disaster. The severe event will come. You cannot, deny it. Like now you have category 4, category 5, to Philippines, to Taiwan, changing from go to the south and then go through the country, which is what is changing. It's unbelievable. And so the building resilient at the community base is the one that they have to face it. They have to get up by themselves. So you have to build that. That's the only way, that what I believe. But the other, maybe people can usually they try to prevent the disaster to happen. Yeah, easy to say, but Mother Earth more powerful than you think. We are in different boats, but we are in the same storm. All hands on decks. Think globally, act locally. Imagine what we can do together. And then stronger together. The lady in the panel is using this also from Africa. So we stronger together is an ASEAN motto a few years ago, and one for all for one. Thank you.
All right. We open the floor for some questions for Chai. Yeah. There, of course.
Of course, Basuki. Of course.
What's your definition about the weather fire?
Okay. Okay, please.
What's your definition about the weather fire?
Oh, okay. Fire weather and weather.
Fire weather, yeah.
Yeah. The thing is, when you have fire, that it has its own weather.
So could be a stable weather condition, right?
No, it's not. It's
Not?
A bit crazy. You can see, for good example now in Japan. Japan having a big fire at the moment up in the northeastern part, and they, with all the technology they have, still cannot control it. This is the fourth or fifth day already, and spreading. Okay, now it's almost 3,000 hectares already. Or in the U.S., when the happened in Los Angeles, that it has its own is synoptic wind and local wind. When it's the big factor is the wind. When the local wind effect of getting fast is out of control. In the U.S., you see the Santa Ana wind happen from the east, come to the west, but they're close to the Pacific. During the day, you show it in your slide, the wind is against it. But during the night, when it combined, when the gust went up to 160 kilometers per hour, then even the U.S. can just watch.
But in Southeast Asia, actually, the definition is different, right?
The fire weather is the same.
Same.
Yeah, the same with
It's
what
about
they
wind.
have, because we don't study that much. We don't really understand it that well yet. So now even the basic equipment that you have to go and you can have forecasts. Okay, like you can have a fire weather index forecast, but actually when you go to the local, you have to measure it again and compute, because at the particular valley, it's a different. This valley can have the wind from this direction, but if it's steep and have a valley, it's different kind, the wind change. Or even on the hill, you're working on this slope, but the wind come this side, is suddenly when this is hot, it might go up this way. So the fire behavior change, the spread rate go to different direction. So you still need to have the fire weather expert, but we don't have it yet. No. Okay, Basuki, please.
Yeah, thank you, Jai. With your expertise and experience, do you have something like, okay, I think you have some data, time series of data, where and when the fire start and end, maybe from the firms.
The data is from the field.
Yeah.
When they detect it, when they attend the fire, when they finish.
Yeah.
That we have, but from the firm, the satellite, well, you have 12 hours different. If the overpass come again and no fire, you cannot say that the fire lasts 12 hours.
Okay. Yeah. Why? That's why I asked about the data, because maybe you can have something like predictive using the AI predictive model. For predictive some or have some pattern about the
they try to use that. There's a guy, I don't want to mention his name, but he got 10 million baht to do this already. But it's just so he saw it one paper in firm. So I asked Diane Davy, is it possible to use the active fire to do this spread rate of the fire? They said no, cannot. You can do it with mega fire, but the small fire like only 50 hectare, 100 hectares cannot, unless they could do it in the U.S. because they have a plane with a thermal camera mounted under the fixed wing and fly over to see the fire front, and combined with the geostationary, they have different kind of sensor than Himawari, which is the Himawari team will copy what they said for the Himawari 10 to use the same sensor as the goes east and goes west.
Yeah. I mean, at least if you have some data, you can run with something like the AI predictive model.
Okay.
Yeah, like I do. I run the AI model. Yeah, but it's not. I just observe the data, because we still get data from the Chris. Yeah, for the
he asked me, he just asked like
for the in the night fire data, and then constantly we have everyday data all around Indonesia. We have right now is more than 100,000 data set. But still, when we try run some model is not really not really good. But yeah, I think we can have this. Collaboration. Yeah. I mean, for example, okay, one of the problem we in Indonesia, we didn't have something like the humidity data. Yeah, it's difficult. Yeah, if we have a humidity data in some specific area, we can maybe make a model close.
So get Addison sensor up.
Yeah, yeah. No,
where are those? It disappear.
Yeah, no, I mean one the problem with the humidity data. Sometimes the sensor is not really. I mean, yeah, not really in the long
has
long
a problem. It's not long. You have to change it.
The temperature sensor is working well.
Yes,
but the humidity sometimes not
maybe he
less
has
than
a new one. He's standing in the back.
Yeah.
No, maybe you have a new version.
Yeah. Yeah, and then when we spread the humidity, yeah, maybe we can.
The thing is, you try to use AI, it's okay. It's good idea. Everybody trying to do that. But in terms of fire, we have a fire behavior model, a lot, like very complex one, like Behave Plus, Permatos.
Yeah.
But to calibrate that or to fix that, like for example, for the Canadian, it took them, I don't know, 50 years of field data collection to do that. And they do it like almost every week.
This is my hypothetical that in the in the equator area, yeah, with the 2 season, it is different with the 4 season, and then a 4 season area. Yeah, in the top, at least in the equator, I think the most important is go to the humidity. Not only the temperature.
We can try to talk about that and then get a project and install more in Indonesia.
Yeah, not only Indonesia. I mean, close to the equator. Yeah, I think the humidity is more.
Of course.
Yeah,
And the soil humidity. Like yesterday, we talking about the depth. What do you measure the depth of the soil that you said talking about the humidity?
Yeah.
Is it how many centimeter? But they have the standard. Maybe you have to go, not maybe, different, like 3 level. You want to measure, you have to do that. But usually we measure on the surface. So it's kind of different.
Okay. I mean that if you can have some data and then we can collaborate. The data among us.
Yes.
Yeah. So we can
not
run
among
the
us.
model.
We will open.
Yeah.
In the open and sharing data.
I mean at
open
least,
data for everybody.
Yeah, at least in the Asia countries.
Yeah.
We can open and then we can compare, get the data.
Definitely.
Yeah, and then we can. Yeah, when I get, I want to get the Sulawesi data. Maybe I close to the Philippine sensor.
Maybe Namlia have it.
It's more accurate.
Maybe. Like bathymetry from the tsunami, Palu, found out that the Indonesian government have all the bathymetry for the whole, I don't know, up to Pacific, Indian Ocean as well. But that we ran for Professor Wu to do the simulation of the Palu tsunami. So I got those bathymetry, 187 meter for him to run. Then the different story. But the Indonesian government have more, but they're not allowed. They have the ship that scan the seafloor. We try to access that, but BPPT, now BRI, they're not give. They said no, it's a classify. So we couldn't.
I don't know what to classify.
Yeah. For you, even for you, classify. Bri. Yeah, everything go to Bri.
All right. One last question before we move to lunch. Okay.
Okay. I'm Addison from AIT. So just answer question from Basuki.
Yes.
Yeah. From the humidity data, you can use the sensor, especially like the Hesmon sensors also indicated that humidity already is. And also, actually, in fact, the humidity sensors and temperature sensor are in the same devices. If temperature sensor is working fine, the humidity should be okay as well. And then to further answer the question, the lifetime span, the lifetime for that humidity sensor is about 2-3 years. So if you been have some diff or some inaccuracy, so you can still working with us, and then we can support from some kind of a small part to send to you and then change it like just more. But the rest of the system is still working, but just some part of sensor. So, and
when the Asia Connect open, we can install more. You know, we put up some proposal. And
yeah, but
try to expand it.
Expand it, or please help to bring them up also. And also,
yeah, and Ren, Indonesian Ren have to bring it up a bit. Please.
And maybe I have one quick question to Dr. Chai also. I have a question, like you mentioned about the burn data, right?
Yes.
That's very useful for firm. Do you have any timeline that they were gonna release that?
Oh, for the usually it's delay,
yeah.
but you can have 25 years of data, if you don't mind, from 2001 to 2024.
No, we need some kind of real time, like.
Near real time, you could assure you could try once a month come out, but you have to use FAO. But the data is not scientific. They have to check. That's why it's slow. So from NASA, they check again. Take like maybe 3-4 months to check. I don't know why taking that long. But FAO will take it right away when it's up online. Every month, monthly, they will update that. So the FAO system will take it because they use a Google Earth engine and automatically take. But to put into firms, they have to verify. Have to be scientific grade data, not just quickly. So.
By the way, what is FAO?
FAO. What is? Whoa, Kamiya, please.
Oh, okay. UNFAO. Thank you.
So yeah, they have it. They have Collect Earth. They have the system that they build for the whole group, Collect Earth, and this is one of the components in there. I'll show you.
Yeah, thank you.
All right, thank you very much, Chai. Let's give him another round of applause. All right, just to end this session with some synthesis. So this session is about sharing our collective understanding of the Earth, its system, interactions of atmospheric, oceanic, and land systems. So at the scientific level, which is our community, it is important to share our resources, whether physical or intangibles, but more importantly, human capacity and skills. Hence, workshops are important. Air quality monitoring is important, of course, innovation in monitors and models, water management to prepare for drought, forest fire control and monitoring, necessitates collaboration among many nations. But as Chai mentioned, it is important to engage and empowers the communities themselves, right? So with all of this, it is actually important for having the impetus to act, actions that must be done to reduce our exposure to hazards. So that ends our disaster mitigation working group session.